Okay, hey guys. The purpose of this video is to go over a few of the questions in video format versus me sending a sheet with a solution on it. I think that this may help you with the problems going forward. Okay, I'm just going to do a few of the questions. I'm going to select them at random. I'm going to talk my way through them, and then hopefully it will help you for the problems that are similar to. You're not going to find a problem that's going to be exactly like it, but a problem where you should have similar thinking. I'm going to start off with question number 12. This is from today's assignment, March 18th, 2020. In question 12, it says if P is parallel to Q, solve for X. So if they are parallel, then the line that cuts through them is the transversal. And we know that with parallel lines comes the alternate interior, alternate exterior angles. Those are congruent. Corresponding angles are congruent. And then you have the pair of supplementary angles. Here, if we look, these two angles, one is on the outside of the parallel lines and one is on the inside of the parallel lines, and they're both on the same side of the transversal. So that means that these two angles in particular are equal to each other. Okay, so I could just write 11x minus 5 is equal to 7x plus 27. And you guys have done really awesome at solving things algebraically. So I think the algebra is not going to be the issue. It probably was setting up the equation. So I'm going to subtract 7x from both sides, and 7x from 11x is going to leave me with 4x. And on the right side, I'm just left with 27. I'm going to add 5 to both sides. So on the left, I have 4x is equal to, and then 27 plus 5 gives me 32. Then I'm going to divide both sides by 4, and I get that x is equal to 8. Okay, I'm going to go back to the question. The question does say solve for x, so therefore I know that my work here is done. Pause the video. Take notes of anything that you may need to take notes on. I'm going to look at question number 14. 14 piggybacks off of question 12, and there's information in 14 that you will find very helpful in question number 13. So 14 says, if A is parallel to B, solve for X and for Y. So first I'm going to solve for X. So the two angles that have X in them are this angle here and this angle here. So when I look, both angles are on the outside of the parallel line. So that means that they are exterior angles, and they're on opposite sides of the transversal. One is on the right side of it, one's on the left side of it. So therefore, they are alternate exterior angles, and alternate exterior angles are congruent to each other. So I could set up the equation 13x minus 27 is equal to 10x plus 6. And then here we are again with the algebra work. So pause the video and take a moment to solve for x yourself. And hopefully you have that x is equal to 11. But I'm going to go back up to the question. The question says solve for x and for y. So therefore I know that I'm not done. So I'm just going to take x being 11. I'm going to plug it into either one of the angles. Okay, I'm going to plug it into this one here. So I'm going to say, well, 10x plus 6 will be equal to 10 times 11 plus 6. And that's going to give me 116. Okay, so what that tells me is that this angle right here is 116 degrees. Okay, and my work with angles, because by now, especially if I've been using IXL, I know that these two angles are supplementary angles, or they are a linear pair. And if they're a linear pair, it means that 9y plus 19 and 116 degrees is going to equal to 180 degrees. So if I want to solve for y, I can write that in an equation. So what was that? 9y plus 19 plus the 116 degree angle is going to equal 180 degrees. So pause the video, solve for y. And you should have for an answer that y equals 5. Okay, so from this question, what is very important to know, or the come away from the question, is that when you have angles that look like these two angles in particular, this 13x minus 27 and a 10x plus 6, that these guys are your alternate exterior angles, and alternate exterior angles are congruent to each other. And then these two angles here, angle 9y plus 19 and 10x plus 6, are a linear pair. They're supplementary, forming a 100-degree angle. Okay. Towards the bottom of the sheet, there are a couple of things that I need to remember about parallel and perpendicular lines. If I want to figure out if a pair of lines are parallel, perpendicular, or neither, I need to remember the things about slope. So more importantly, if I'm given the ordered pairs, I can use the slope formula. And the slope formula is that change of y over the change of x, or m is equal to y2 minus y1 over x2 minus x1. And that's something that we use all the way back in probably like 7th grade. And then the other thing is that if I want to compare two equations of lines to see if the lines are parallel or perpendicular, I would either want them to be in slope-intercept form, which is y equals mx plus b form, or in standard form. And in standard form, that one is, we have ax plus by is equal to c. Okay. It says describe the slope of parallel lines. Parallel lines have the same slope, and perpendicular lines have negative or opposite reciprocal slopes. So negative reciprocal slopes. Okay, and an example of that would be 1 over 4 and negative 4. So 1/4 and 4 are reciprocals, and notice that 1/4 is positive and 4 is negative. So one is opposite sign of the other. In questions 16 through 17, I'm going to do 17. So if I look at this line and I think back to like my math 8 work, when a line goes straight up, it's like that mountain or hill that you would never want to have to walk up or ride your bicycle down, because it seems like you're going straight up to the sky or going straight down to the ground. And that guy has a slope that is undefined. Okay, so if a line is parallel to this line here, then that line has to also have a slope that is undefined. And if it is perpendicular to it, means that it forms a 90-degree angle. So because this line is vertical, we will look at a line that is horizontal, and a line that's horizontal to it is going to have a slope that is 0 slope. Okay, and that's a nice flat steady line, no increase, no decrease to it. I'm going to go ahead and jump down to question number 19. The directions for question 18 through 20 is determine if segment AB and segment CD are parallel, perpendicular, or neither. So the way that I could figure out if two lines are parallel, perpendicular, or neither is to compare their slopes when I'm given the ordered pair. Okay, so I'm going to set it up, and then I want you to pause the video and then fill in the information in between. So first, I want you to find the slope of AB. Okay, and remember the slope formula is the change of y over the change of x. And you should have that the slope of segment AB is negative 3, sorry. Next, what I want you to do is find the slope of segment CD. And you should find that the slope of segment CD is also negative 3. Now, compare the two. Because negative 3 equals negative 3. The lines are parallel. So I'm going to write here, negative 3 equals negative 3. So therefore, they are parallel. Okay. So going through this process should help you with 18 and 20. Your job is to first find the slope of the two line segments, and after you find the slopes, compare them. Okay, so if they're the same, like here we have in 19, then that means that the lines are parallel. And if they are opposite reciprocals of one another, they're perpendicular. And if they are neither equal to each other or opposite reciprocals, then they are neither parallel or perpendicular. Okay. All right, so jumping down to question number 21, I'm going to do question 21 and 23 for you. Question 21 and 23 says determine if the equations are parallel, perpendicular, or neither. And if I look here, I'm not giving points like I was in the previous 3 problems. I'm giving the equation of the lines. So what I could do is I could either write the equations of the lines in slope-intercept form, or I could write the equation of the lines in standard form. Okay, it is much easier if you write the equations of the line in slope-intercept form, because then you see the slope and then you can compare the slopes. So for instance, looking at question 21. The very first equation is already written in y equals mx plus b form. So I'm going to take the second equation, x minus y equal to, and rewrite it so that it is y equals mx plus b form. And that just means I'm going to solve for y. So in solving for y, I'm going to subtract x from both sides. And I get that negative y is equal to negative x plus 2. Always have the x term in front of the constant. And then to continue solving, y is not by itself yet, so I'm just going to divide out the negative, which means everything changes signs. So instead of a negative y, I now have a positive y, negative x now becomes positive x, and a positive 2 now becomes a negative 2. So now I have the equation y equals x minus 2, and the other one is y equals x plus 6. And both of them have a slope of 1. So because they both have a slope of 1, it means that the lines are parallel. Okay. Take a second and pause the video if you need to, but I'm going to go ahead and jump down to question number 23. I'm going to do the same exact thing. My job here is to put both equations of the line in slope-intercept form, because when it's in slope-intercept form, the coefficient to my x term is my slope. So the very first equation is 4x plus 3y equals 9. So I'm going to move the x term over. So I have 3y is equal to negative 4x plus 9. And then to get y by itself, I need to divide out the 3. So I get y is equal to, I'm going to leave this as a fraction, negative 4 over 3x plus, and then what's 9 divided by 3? 3. The second one, I have 3x plus 4y equals 36. So I'm going to move over the 3x term. So I get 4y is equal to negative 3x plus 36. I'm going to divide everything by 4 to get y by itself. I have y is equal to negative 3/4 x plus, and then 36 divided by 4 gives me 9. Okay, so here I have my slope here is negative 4/3, and my slope here is negative 3/4. Okay, now negative 4/3 and negative 3/4 are reciprocals of each other, but they're not opposite reciprocals because they both have the same sign. They're both negative. So these lines are neither parallel or perpendicular. Now, hopefully this video helped. You can always listen to the video as many times as necessary to help you through the questions. Okay? Peace.